from here to here, then that's successful there as well. Make sense? Now, whenever you can say that if I send traffic from any PC to any PC, then the communication actually is happening there. But what we want in this particular scenario is we don't want these PCs to communicate with each other, the other PCs to communicate with each other, and the other PCs to communicate with each other, which means we logically want to create this as a different group, this as another group, and this as another group. In this scenario, then, I'll just distribute them differently by selecting a color here. Let's say this is our VLAN 10 color. Then I select some other color over here by saying this is VLAN 20 color, and then I will say like this as VLAN 30 color. You see that? That's how differently the data is. And if we can tag them, I'll also tag them as VLAN 10, VLAN 20, and VLAN 30. Okay. Now by default, if you look at the switch, then you can see it over here that by default all the switch ports, because the switch has 24 fast Ethernet ports, right? And if you look at the other things, then there are 2 gigabit Ethernet ports as well, which are part of VLAN 1 and VLAN 1. But by default, you can check the third column into the statistic page, and every port is member of VLAN 1. And out of the total ports, only first 6 ports are up, right? The fast Ethernet 1 through fast Ethernet 6. These are the 6 ports that are on. Now, if I check the console, or if I go to the CLI of the switch, the CLI of the switch is almost same like a router. We'll go away into the enable mode, conf mode, and I will rename that particular router as host name. You can say switch 1. And then in order to check the VLAN table or VLAN database, you can run a command called show VLAN brief, or do show VLAN brief from the config mode. Yeah. And there you go. So you have a by default VLAN 1 that has been created, and you cannot do anything to this VLAN. Makes sense? Everything that you can play with into this particular VLAN is through FA0/1 to FA0/24. Sounds good. And all of these ports that you see are a member of the VLAN number 1. Now what we need to do, we need to create 3 different VLANs. Okay, because according to our topology, we have VLAN 10, which is actually sales department. Then we have VLAN 20, which is actually marketing department. And we have VLAN 30, which is admin department. You get that? Now in the sales, marketing, and admin department, you can say that whenever I go onto the switches CLI, I can create VLAN just by using a command called VLAN space and the number of them. So the first VLAN is going to be VLAN 10, and you can create VLAN in a range of 1 to 4094. You can have VLANs as 1 to 4094, but you can create it between 2 to 1001 only. Okay, because VLANs are grouped into different categories. You have some standard VLAN, and you have then the extended VLANs. Okay, for the normal communication perspectives, we use standard VLANs, which actually ranges between 1 to 1001, and then 1002 through 1005. These are reserved VLANs, you cannot use them. And then from 1006 to 4094, that's going to be your extended VLANs, which we actually use for voice and wireless traffic. So for standard traffic, we actually use you can say for standard traffic, we use VLAN number 1 through 1001. But 1 is by default created, so the actual range that you can actually create your VLAN is 2 to 1001. And that's going to be a question into your CCNA exam. Okay. So we are going to create a VLAN 10. And for that, the command will just be simple as VLAN space 10. And then we can name that particular VLAN by using name command and space. The name of that VLAN will be given like that. Okay. Then we can take an exit and then say VLAN and create the other VLAN 20, name marketing. Okay. Take an exit, then VLAN 30, and you can say that name is admin, or let's say what's the name of our VLAN? It's admin, yeah. So we go and say name admin and then take an exit. And you can verify the same by saying do show VLAN brief. And there you go. Sales, marketing, and admin. These are the three VLANs that you have created. But you can see that there is no members that are assigned. So far, creating a VLAN is as important as assigning the members, or making the ports as member of that VLAN is as important as creating a VLAN. Otherwise, there is no point in creating the VLAN. You get that? So sales, marketing, and admin, these three are the VLANs that you have there. And then after that, you can say that whenever, if I, like right now, even after I have created these VLANs, the communication is still possible between the PCs. You see that? Successful. If I send from this PC to this PC, it's also successful. So what you need to do, you need to make, and still you can see all the ports are member of VLAN 1. So you need to make the membership into the dedicated VLAN. So like port number 0/1, you can see over here 0/1 and 0/2. You can see that 0/2, yeah. So 0/1 and 0/2 needs to go to VLAN number 10. 0/3 and 0/4 needs to go to VLAN number 20, and 0/5 and 0/6 needs to go in VLAN number 30. And how do you do that? You go to the CLI of your switch, and then you select the interface by saying interface FA0/1, and then make it a member of VLAN 10 by saying switch port access VLAN 10, like that. Then you go to the next interface saying interface FA0/2 and say switch port access VLAN 20, VLAN 10. And then when you check it, do show VLAN brief, you can see that the port number FA0/1 and FA0/2 are now member of VLAN number 10. Just like that, you need to make the members associated in VLAN 20 as well and VLAN 30 as well. The switch port is basically part of the syntax. Then you say that's the mode of the port, okay? And then you say VLAN space the number of your VLAN. Now, when you have multiple, you can say interfaces that actually needs to be made member of a single VLAN, then you can select a range of interface. Like the next interfaces that we need to put in VLAN 20 are 3 and 4. So instead of selecting individually every interface, I'm going to say interface range FA0/3-4. So you can select a range of interfaces like that. So it's going to select FA0/3 and FA0/4. And then I'm going to say switch port access VLAN 20 and take an exit. And then if I say do show VLAN brief, you can see both the ports are now member of VLAN 20. And then I'm going to do the same thing for 30 as well by saying interface range FA 0/5-6 and then say switch port access VLAN, you can say 30, and then take an exit and verify the same, do show VLAN brief, and there you go. The membership has been taken off now from VLAN number 1, and they are now attached, or they are now members of a specific VLAN that are there. And now if I come back to the topology that's here, and if I try to send traffic from my first PC to the second PC, there you go, successful. If I try sending traffic from PC second and PC third, successful. PC fifth and sixth, there you go, successful. But if I try send traffic from green to red, which means from VLAN 10 to VLAN 20, it's gonna go failed. You understand that? And if I try to send traffic from here to here, it's also gonna go fail. which means the communication between different VLANs are limited. Okay, and the switch ports can only now communicate with the same ports or with the ports that are member of the same VLAN. Do you understand this? When you have multiple ports like 10, 20, or whatever it is, you can select a range of those interfaces, and then you can make them like member of that particular VLAN. It's not required to select one by one, like going into every interface and then making it a member of that particular. You can directly select a range of interfaces and then entirely assign that range of interface to a specific VLAN. Yeah, for different VLANs to communicate together, you need a router. We're going to talk about that, okay, for the routing and all the other things. So go ahead, try the small lab of creating the, you can say, VLANs and see if it works for you. And then we'll move on to the next one that's called how you can implement trunking. Okay, try this lab and I'll see you around in 10 and 15 minutes. Okay, give yourself a try about that, and then we'll move on to the next topic. Thank you. Hey guys, I hope you are done with the lamp, and let's move on with the next concept that we have. I hope I'm audible to all of you. Perfect. Now, here we have three groups, right? We have this VLAN 10, then we have a VLAN 20, and we have a VLAN 30 as well. That actually is allowing us to communicate inside the VLAN itself, which means we cannot really communicate from VLAN number 10 to VLAN number 20, or to VLAN from VLAN 20 to 30. But what if you have a scenario in which the switches are there itself, and let's keep it differently here and over here inside the VLAN. Yeah, like that. And you have another switch. So I'm going to design an exact replica of this network over here, and we're going to use the same network 192.168.1.0 there. So I'm going to go on to network device, grab a switch. Just a minute. Yeah, hey there. Sorry, that was a quick call that I had to receive. Anyways, so as I told you, I'm going to create a replica of this network here. And if I say 2960 here, and then I'm gonna grab such more devices. So let's say these two are the ones, then you have another one, and these two are the ones. And then if I connect them together from here to here, from here to here, and from here to here, and then you can say from here to here as well, and here to that piece. Right? This is how your 6 devices can actually be connected in a way. And then you can again think of it like fill the color for these VLANs. And then I'm going to create a small circle for this, which is VLAN 30. Then I say create a red box for VLAN number 20, and then create a green box for VLAN number 10. There we go. VLAN 10, then you have VLAN 20, and you have VLAN 30. Then I'm going to assign them the IP addresses that we have. Okay, so I'm going to go on to the PC1, and I'm going to continue with the same range of IP addresses that we have. So we have assigned from 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. I'm going to continue with 7, 8, 9, 10, 11, 12. So I'm going to go on to this PC and go to the desktop and IP configuration, and 192.168.1 dot can say 7, and then desktop and IP configuration 192.168.1.8, and then desktop IP config 192.168.1.9, and close that and go back here on the next PC, desktop, and you can say 192.168.1.10. Oops, 192.168.1.10, and close that as well. And then go to the fifth PC, desktop, IP configuration, and 192.168.1.11, and go to the next one, desktop, IP config 192.168.1.12, and that's all. So the IPs are configured on this particular PCs as well, and if we look if they communicate together from here to here, successful, then from here to here, successful, and from the last set of PCs successful, which means they all will communicate together as well because they are in same VLAN. Understand that? Now, if you look at the switch statistics, you can also see it's the same, which means that the switch has around 6 interfaces that are there, and they all are in default VLAN number 1. However, if you look at the switch number 1, then we have 3 different VLANs. You can check that into the third column, that 0/1 and 0/2 is a part of VLAN number 10, 3 and 4 is part of VLAN number 20, and 5 and 6 is part of VLAN number 30. Now I'm going to go on to the CLI of our new switch, and I'm going to configure 3 VLANs there. Okay, just like we did on switch number first. I'm going to go and rename this as switch 2. Go to enter, go to first VLAN 10. Okay, because if I check do show VLAN brief, then you can see that there's just one VLAN that's present there. So I say VLAN 10, name sales. Okay, exit VLAN 20, name marketing. Okay, and take an exit, and VLAN 30, name admin, and take an exit. And then I'm gonna grab the range of interfaces. So that's again gonna be same 0/1 and 2, 3 and 4, and 5 and 6. Okay, and it doesn't matter how many interfaces you actually want to select. Okay, the moresoever the number you're using are valid, you can select the number of interfaces in a range. So you can say interface range FA0/1-2. Okay, and if you want like different groups of interfaces, then you can say like 1-2, comma FA5-6. You can go like that as well. So it will select from 1 to and from 5 to 6. Otherwise, you can directly say from 1 to 6. Or you want selected interfaces, then you can say 0/1, FA0/5, FA0/7, like that as well. Okay, so we are selecting currently FA0/1-2, and then we will say switch port access VLAN 10 and take an exit. Then I'm going to go and say interface range FA0 slash 3 and 3 hyphen 4 switch port access VLAN 20 and say take an exit and say interface range FA0 slash 5 and 6. Okay, switch port access VLAN 30 and take an exit there as well. Make sense? Now, if I go and check do show VLAN brief, then you can see sales, marketing, and admin. These three are the VLANs that are created there. Okay, and if I show you whether these guys communicate together, because what I'm going to do now, as I want VLAN 10 to communicate with VLAN 10, 20 with 20, and 30 with 30. So if I go ahead and connect this over here, then you see the interface that we're using is 7. And if I turn that particular interface up, you can see that the communication between green and green is successful. But if I try doing communication between this green and this green, it says the last packet says failed. Why is that? Now here's the thing. We are talking about a concept called trunking, right? And the way that we use trunking in this particular scenario is in a way that you can now check over here that we have this switch and we have the other switch. So these group of interfaces are part of VLAN number 10, and these group of interfaces are part of VLAN number 10. But when the traffic actually goes to this switch, then the switch is identifying that the PC is connected to VLAN number 10. So the switch tags that particular frame with a VLAN ID or with something called as VLAN tag. And this VLAN tag is of a 4-byte header value. Okay, and that particular value is going to identify that frame as a part of VLAN number 10. Okay, now what's going to happen whenever a switch looks at that particular traffic that's coming from VLAN 10, it recognizes that particular frame as it can only be forwarded on a port that is a member of VLAN number 10. Now tell me one thing, in order to make this particular communication reach out from here to here to here, then the port number FSL/0 needs to be a member of that particular VLAN. Do you understand what I'm trying to say? Because currently this FA0/1 is member of VLAN number 1, and the port from which the traffic is actually coming or being received is a member of VLAN number 10. So the communication between FA0/1 and FA0/7 is not possible. Do you understand that? Right? And for the same reason, what can be one of the solution? The one of the solution can be that if I can make FA0/7 as member of VLAN number 10, and that would basically make 10 to 10 communication successful. But what about then 20 and 20? So every time I need to make changes into FA0/7, and that's not something that is possible, right? So for the same concept, what we are going to do is we are going to have something called trunking with us. And we are going to make this link as something called trunk link. Okay? And the trunk link is going to make this particular port on both ends remove the association of VLANs from, you can say, every VLAN that is. Because currently you can see that FA0/7 is actually a member of VLAN number 1. Do you see that? It's there. You can see it over here that FA0/7 is member of VLAN number 1. And we're going to remove that association of FA0/7 by configuring it in a way that will make this particular port as a trunk port, and it will basically not be member of any VLAN. You get that? So whenever you configure, like there are two ports or there are two modes a switch port can have. Your switch port can either be an access mode or your switch port can either be in a trunk mode. Just a minute, guys. Yeah. So I'm going to make that particular port as a trunk port because as I was telling you that your access that your switch port can either be an access port or it can be a trunk port, right? So if it's an access port, then it needs to be member of one VLAN, right? And if it's a trunk port, then it will not be member of any VLAN, but it will be able to communicate with all the VLANs that are there in your database. Makes sense. So access port only can talk with the same VLAN that it's a member of, and trunk port can talk with all the VLANs that are present into your VLAN database. Do, do you understand that? Perfect. So I'm gonna go and I'm gonna configure the FA0/7 as my trunk port on both the switches. So I'm gonna go onto this switch, say enable config. If I say do show VLAN brief, there you go. FA0/7 currently is a member of VLAN number one. And I'm going to go into interface FA0/7 and then I'm going to say switch port mode trunk. And the interface will go down and it will come up again. I'm going to go onto the other switch and say interface FA0/7 and switch port mode trunk. Okay, and then I'm going to take an exit and wait for the interface to come up because it has went down now and it will take some time to come up. And there you go, the interfaces are up now. And if you check the statistics of your FA0/7, can you see the port is no longer associated with any VLAN? You can see a double hyphen mark there on the third column where it like right next to the FA0/7. On the other side as well, you can check that FA0/7 is part of no VLANs now. And you can check the same as well by performing do show VLAN brief again, and you will not find FA0/7 there anymore. Okay, and on the other side as well, you can see do show VLAN brief. There you go. Makes sense? That's how the things are here. Okay, and now in order to check your trunk table, you can perform a command like do show interface trunk. And when I perform this do show interface trunk, it shows my FA0/7 has a trunk mode on. The encapsulation that it's using is .1Q, and the trunking link, the status of that particular interface is trunking, and the native VLAN is 1. Okay, however, that's none of your concern as of now. What's native VLAN and what's encapsulation? We'll talk about it somewhere else. But yeah, the VLANs that are now allowed by the interface to be communicated is VLAN number 1, 10, 20, and 30. And on the other side as well, if I say do show interface trunk, then you can see that VLAN number 1, 10, 20, and 30 are allowed to be sent. That's how trunk actually works. And then when I go into my topology and when I try sending traffic from this PC to the other PC over here, it's successful. That's exactly how it works. So that's trunk, guys. Go ahead, try this particular thing and see how it works for you. Okay, it's a lab time, and then I'll come back to you. Thank you. Hi guys, let's move on to the next thing that we have here. And we're going to talk about inter-VLAN routing now. Okay, now you can see over here that there are multiple VLANs that are present. And if I want in the same topology that I want this PC to actually communicate with the other PC, then there you go, the communication is actually happening, right? And if I want the communication from VLAN number from this VLAN 10 to the VLAN 10 here, then the communication is it not going? Yeah, successful. And if I try to send traffic now from here to here, which is VLAN 20 communication, it's also working there. And then from VLAN 30 to VLAN 30 there. And then you can see the communication is working there as well. Make sense? Now, when we try to communicate between two different VLANs, that's where the problem is. Because currently there is no communication that is happening between two different VLANs, which means VLAN 10 and VLAN 20 communication cannot really work. So as of now, I am going to detach the connection that you have here, and I'm gonna delete this link here, which is here. And I'm gonna take this particular network out somewhere, and then we are just going to focus on this network. Drag it like it over here. Now, in order to make this communication, what actually you need to do is we are talking about a concept that stands for IVR, inter-VLAN routing. And IVR has two different methods that you can actually implement. Okay, one is called as routing on a stick, and the other one is called as SVI, switched virtual interface. So routing on a stick is actually done when you have a router, and with that particular router you actually can make the communication of different VLANs possible. Okay, or you need to have a layer 3 switch there. Okay, because if you talk about this switch, then this is a layer 2 switch. In that case, the communication between different links or different VLANs are not possible, because whenever we talk about a topic that's IVR, we talk about inter-VLAN routing. And inter-VLAN route for implementing routing, anything that is concerned with routing, layer 3 comes up in between, because routing is possible only when you're having layer 3 networks inside your topology. Make sense? Now, what we need to do in this case, we need to replace this layer 2 layer 2 switch with a layer 3 switch. So I'm gonna grab a layer 3 switch and I'm gonna connect that layer 3 switch with all the pieces that we have here. Okay, and to implement that, I'm gonna click on this delete sign. I'm gonna delete this switch, and then from the networking section, I'm gonna go to the switch, and then I'm gonna grab a layer 3 switch, which can be our 30, 35, 60. Okay, so I'm gonna grab this switch here, and then I'm gonna connect it with all the other PCs that you have. There you go. We have connected all the pieces, and still the communication now, or the way that the communication will be done, is only if I try to send traffic from here successful, here successful, and from here to here as well, it's gonna go successful. If I try and send traffic now from here to here, it's also successful. Why is that? It doesn't mean that we just have implemented IVR just by connecting a layer 3 device. Okay, it's because the switch doesn't have any of the configuration yet. That's why all the ports that the PCs are connected with are part of our VLAN number 1. And that's why they're communicating together. Okay, but what we need to do, yeah, we didn't configure VLAN. So we also need to configure VLANs and make those particular ports as member of the respective VLANs again there. So I'm gonna grab an access of that particular switch, and I'm gonna configure whatever configuration we did on layer 2 switch in order to make it work. So by taking a layer 3 switch, I'm gonna grab the console of that, and I'll click on this. There you go, on a CLI, and there you go. You say no here, enable host name, you say M multi-layer switch 1, okay, or layer 3 SW1. Oh, we need to go into conf and then we say host name layer 3 SW1. And then I'm gonna go and create different VLANs by saying, because if we check do show VLAN brief now, there's no VLAN that is created. So we say VLAN 10 name sales, then exit VLAN 20 name marketing, and take an exit and you say VLAN 30 name admin. Oh sorry, name admin, and then take an exit there. Sounds good. And then after that, I'm gonna say interface. Now if we check the range of interfaces, the interface that this multi-layer switch is using is again same, FA0/1 through FA0/6. So I'm gonna take the first two ports, assign it to VLAN 10, the next two to 20, and the next two to 30. So I'm gonna go on to the console again, and I'm gonna say interface range FA0/1-2 switch port mode. Switch port access VLAN 10. Then take an exit, interface range FA0/3-4, switch port access VLAN 20, take an exit. And then interface range FA0/5-6 and switch port access VLAN 30, and then take an exit. You get that? So that's how we have our VLANs ready. You can verify that as well, that we have assigned these ports to the VLANs. And then if I go and check the connectivity, then the communication between the VLANs are now blocked, but the communication between the same VLAN is again possible. Now here, whenever your PC actually wants to forward a traffic, whenever the communication between two VLANs needs to be done, then in that particular case, what actually you need is the PC needs to go to the device, okay? And then that particular device also needs to maintain a layer 3 routing table, because what's going to happen is these PCs might be in the same network, or these PCs might be in the different network as well, okay? This actually depends on a way that it's functioning. So what's going to happen in this particular case is that we are going to configure these PCs with different networks, okay? And we will make the configuration in a way that the first VLAN has a network of 192.168.1.0/24. Sorry. And then we're gonna make VLAN 20 as 192.168.2.0/24, and we're gonna say 192.168.3.0/24. Okay, this is how we have all the network set up there. And what we're gonna do in this particular scenario is we're gonna configure that. Just a minute, guys. Yeah, so we're going to configure these IP addresses along with their gateways. But for that, we actually need to create on the switch something called SVI. And SVI stands for Switched Virtual Interface. Okay, SVI, Switched Virtual Interface. So this SVIs are the virtual interfaces that we are going to create onto the device. Okay, like we will be creating VLAN 10, VLAN 20, and VLAN 30. And these are going to be like interfaces. So we're going to say interface VLAN 10, interface VLAN 20, interface VLAN 30. And these three are going to be the virtual interfaces that will be created onto the switch. And then we will assign some IP addresses to these VLANs, which means a layer 3 address. So we're going to assign 192.168.1.1 to the first SVI that we have. Then we're going to assign 2.1 and we're going to assign 3.1. And these addresses are going to be the gateway addresses there onto the PCs that you have here. Do you understand what I'm trying to say? So when I configure an IP addressing over here, then I need to go and assign 192.168.1.2 as an address. And then I need to make 1.1 as my gateway then. Okay, so in order to do that, what we're gonna do in this scenario is I'm gonna go onto this particular PC, and I'm again gonna fix the IP configuration here by going onto this PC IP configuration 1.2 and change the gateway, or you can say desktop IP 192.168.1.2. Oh, okay. So what we need to do is we need to change the IP config over here by saying, okay, let's maximize that first. And we're gonna power cycle these devices. There you go. Power cycle the device, which means they should not have the IP address now. Or they still have. That's fine. So I'm gonna give 1.7 over here, and the gateway, oh no, the gateway I believe is going to be 3.2 and 192.168.3.1. You see that? Why is that? Because this is this PC which actually needs to be part of 3.0 network. Then I go to the second last PC, IP configuration, and then I'm going to change the IP to 192.168.3.3, tab 192.168.3.1. Then after that, I'm going to go onto this PC and I'm going to configure a 2.0 network for this PC by going to here 192.168.2.3. 192.168.2.1, and then close this, go to the second PC and the IP configuration, and then 192.168.2.2 there, and 192.168.2.1, and close this. Then after that, open up this PC, go to IP configuration, change it to 1.3, and the gateway will be 192.168.1.1, and then close that PC, go to the first PC there, then go to the IP config and say 192.168.1.2, 192.168.1.1. That's how you actually come up with the IP address configuration. Sounds good? So these two PCs are part of 1.0 network, then you have 2.0, then you have 3.0. Now after you configuring the IP address here, we're going to go onto the switch and configure the SVI. So right now you can see that the VLANs are created of this particular switch, and I can say, oh, the machine was powered on. Okay, so I'm gonna configure it again, saying host name layer 3 multi-layer, oh sorry, ML switch 1, and then say VLAN 10 name as sales, VLAN 20 name as marketing, and VLAN 30 name as admin. And then I'm going to say interface range FA0/1, switch port access VLAN 10, interface range FA0 slash, oh sorry, FA0/2, switch port FA0/2, switch port access VLAN 10, interface range FA0/3-4, switch port access VLAN 20, and interface range FA0/5-6, switch port access VLAN 30, and take an exit there. Do show VLAN brief, and your VLANs are ready there. Then after creating the VLANs, you need to create SVIs. So you create SVI by saying interface VLAN 10. Okay. And when you say interface VLAN 10, then you need to turn those interface up by saying no shutdown and configure an address that is part of that particular VLAN, like this. And then I can take an exit there, and you can verify the SVI creation by saying show IP interface brief. And when I say that show IP interface brief, on the last, you see VLAN 10 SVI has been created and an IP address has been assigned. Just like that, you need to create SVIs for interface VLAN 20 and say no shutdown and then IP address as 192.168.2.1 along with the subnet mask. Oops, the spelling of address is wrong. There you go. And then you're gonna say interface VLAN 30, say no shutdown and IP address 192.168.3.1 along with the subnet mask and take an exit there. Make sense? So if I say show IP interface brief, you have 10, 20 and 30. And then if I go to the PCs can actually communicate with the switch there. There you go, successful. And from here, successful. And from here, successful. So the communication between switches and that particular gateway is happening. I can also confirm that by going into command prompt and say ping 192.168.1.1. So the gateway communication is working. But if I try to send traffic from 1.1 to 2.2, it's still not going. You understand that? Which means the communication is limited in a way about how it's going to work there. So for the same, what we are going to do is, in order to make this particular thing work, I can in order to make this particular thing work here, what we can actually do is we can go onto this multi-layer switch, and the reason that why it's not working is if I check the routing table is empty. Okay, and as the routing table is empty, whenever the traffic actually is being received by the switch, it's not able to identify the destination network, and just because routing table is not there, it's not able to forward the traffic between two different VLANs there. Make sense? So you need to, by default, in a layer 3 switch, routing features are off and layer 3 features are off. You need to enable those layer 3 features by going into conf and saying IP routing. And when you use this IP routing command, then and then only you can check your routing table. And there you go. Now your routing table is updated of a layer 3 switch, and it now knows about all the networks. 1.0 is connected to VLAN 10, 2.0 is connected to VLAN 20, and 3.0 is connected to VLAN 30. So it tries to identify the traffic according to the VLAN tag and not according to the incoming interface. And now if I try to send traffic between different VLANs from here to here, successful. And from VLAN number 20 to VLAN number 30, that's also successful. Make sense what I'm talking about? That's exactly how inter-VLAN routing can actually be achieved by implementing it on a layer 3 switch. Okay, and there is another way that you can implement it by using a router, which we're gonna talk about in the next lab that we're gonna do today. So go ahead, yeah. If I have some questions, so layer 3 switch is more advanced. Well, you can say that a layer 3 switch is always a good option to aggregate your traffic. But in terms of handling big routing traffic and in order to figure out the best way to send traffic from one place to other place, then at the edge of the enterprise, you always put a router, not a layer 3 switch. So layer 3 switch is good for doing routing and all the other stuff, and even the switching for the internal network. But whenever the communication needs to be done different, like with different buildings and different networks together, then you put a router on the boundary. Yeah, the IP routing is basically a command that you actually need to The IP routing is actually a command that you need to use in order to make your layer 3 switch act as a layer 3 device, which means it can actually forward traffic into the layer 3 mode as well by considering the IP address. That's why we need to enable routing features onto the device by using IP routing command. Make sense? Go ahead, try this particular lab and see if it works for you. And then we'll move on with the next lab. Okay? Thank you. Hey guys, I'm back. Let's move on with the next thing. I hope I'm audible to all of you. Perfect. Now, moving on, the next segment is, or this segment is going to be about implementing IVR or inter-VLAN routing by using router and not a layer 3 device. So this was our topology that I actually used in order to implement layer 3 SVI, or you can say switch virtual interface. And then this is going to be another network, or let's say, yeah, this is going to be another network uh, that we already had, which is having IP address from the same subnet now. But then we're going to connect this switch with a router. So I'm going to go and take a router there. And then this router is going to be connected with a switch here. You see that? So what's going to happen is these the networks of VLAN 10 are going to get an IP address of 1.0. That's going to be 2.0, and that's going to be 3.0. Okay, or you can say 3.0 over here. And then we are going. So when we talk about ROAS, which actually stands for routing on a stick. This is what ROAS means, routing on a stick. And when we implement routing on a stick, then we actually need to create sub interfaces onto the router. You understand that? So what's going to happen in this particular scenario is we have one physical interface, which is this FA0/0, right? Now on this FA0/0, we are not going to configure any IP, but we're going to create three sub interfaces. First subinterface will be FA0/0.10. The second subinterface will be FA0/0.20. And the third subinterface is going to be FA0/0.30. Now this 10, 20, and 30 are exactly the same as VLAN 10, VLAN 20, and VLAN 30. So we're going to map these three sub interfaces with the VLANs, okay, that they are using, and then we're going to configure three different networks onto different sub interfaces, but that are all of them are actually part of same physical interface. So on the first sub interface, we're going to have a 1.0/24 network. On the second one, we're going to have 2.0/24. And on the third one, we're going to have 3.0/24 network. Make sense? So just like we had like virtual interfaces on switches, we're going to have sub interfaces, which are again virtual interfaces onto the router. And then we're going to map them with the respective subnets or with the respective VLANs. And then that's how they're going to communicate. The additional benefit that we're going to have here is we can configure DHCP parameters for each network that you have here as part of the sub interface. And then we will also need to make this FA0/7 of the switch as a trunk link so that different networks can actually cross this link and reach out to their network. Make sense why we need trunk over here? I hope you understand that. Perfect. So let's go and see how the communication of these sub interfaces will actually be done. So I'm going to go on my switch. My switch is already configured with like the switch doesn't have any VLANs as of now. So I'm going to go on to my the switch first. That's my switch. I'm going to close all the other parameters there. There you go. Enable conf host name layer 2 SW1. And then I'm going to say VLAN 10 name sales exit VLAN 20 name marketing exit VLAN 30 name HR exit. Oh, sorry, HR exit or whatever that name is. And then I'm going to map the interfaces by taking interface range FA0/1-2 switch port access VLAN 10. Then I'm going to say interface range FA0/3-4 switch port access VLAN 20 and say interface range FA0 slash 5-6 switch port range, switch port access VLAN 30. That's how we create VLANs, and then if I check do show VLAN 3, there you go, 3 VLANs are created with the members along with them. Then I'm going to go on to this FA0 slash 7 and I'm going to say switch port mode trunk, and that's all that you actually need to configure onto your switch here. And then every other configuration will actually be done onto the router. Are we clear here? Any questions till now? Perfect. Then after that, I'm going to go on to the router, which is this. Excuse me. And then I'm going to say no here. Enable conf interface FA0 slash 0. Now for this main interface, we are just going to turn that interface on, and that's all. We don't need to do anything inside of that interface. If you check, I have not configured any IP address on the FA0 slash 0, and I've just turned them on. Okay, I'm going to close this. Open up the router now there. Yeah. So I'm going to go into interface FA0 slash 0, and then from here, I'm going to say interface FA0 slash 0.10. Okay, and you can see that a new sub interface has been created. It says interface FA0 slash 0.10 is changed to state up. You don't need to explicitly no shut this interface because the parent interface is already up. So that's why you don't need to apply any no shutdown command onto the sub interface. The only thing that you need to apply is you need to map this sub interface with the VLAN that you have. And for that, you have a command called encapsulation.1q 10. Okay, by using this command, we are mapping this sub interface with the VLAN number 10. And then I'm going to configure an IP address like 192.168.1.1 along with the subnet mask. And then I'm going to say, I'm going to also create a DHCP pool for sales by saying network 192.168.1.0, 255.255.255.0, and then default as 192.168.1.1. Do you understand this? Perfect. Just like that, I'm going to go and create another interface FA0 slash 0.20 and say encapsulation.1q 20 and say no shut, and then say IP address 192.168.2.1 along with the subnet mask and IP DHCP pool B and say, let's say IP DHCP pool B and then network 192.168.2.0 along with the subnet mask and default is 192.168.2.1 and take an exit. And then I'm going to configure the third interface, which is interface FA0 slash 0.30 and encapsulation .1q 30 and then say IP address 192.168.3.1 along with the subnet mask. And then IP DHCP pool HR and say network 192.168.3.0 along with the subnet mask. And IP DHCP pool HR. We also need to configure a default gateway of 3.1 and take an exit. Are we good here? And then if I check my routing table, do show IP route, you can check that all the three networks are connected there. And if I say the running configuration also highlights all the three DHCP pools there and the three IP address three sub interface configuration. And now if I go onto the PCs and if I try to configure the IP address on these PCs by using DHCP and not using the static IP, there you go. The first PC is receiving the subnet of a DSCP that is dedicated, of a network that is dedicated to VLAN 10. Then if I go on to the third PC directly, and go to the IP config and configure it, it should get an IP address of 2. There you go, 2.0 subnet. And if I go on to the next network or the next PC and go to the IP config and request for DHCP, it should get an IP address of 3.0 net. There you go. So this is how you actually configure. And when I send traffic from here to here, the first packet probably will be failed, the second one successful. And then from here to here, it's also gonna go successful. There you go, successful. So that's how you implement inter-VLAN routing by using help of different VLANs and different networks there. And by implementing it in a production environment, you can achieve greater scale, you can achieve greater control, you can achieve greater security in terms of making and keeping your networks alive. I hope you understand the concept. Any question over here? Well, ROS, you can say, yeah, it can be said that it's better than SVI because it allows you to fully utilize the features of a router. So yeah. All right. Go ahead, try this particular lab and see if it works for you, and then we'll be good for the layer 2 concepts that we had to discuss. Yeah, you got DHCP as well in ROS. Okay, try this lab and let me know when you're done. All right, guys, I hope the labs are done there. And are there any questions from ROAS? Perfect. Then I would say that was basically all that we had to discuss in this particular session. We covered almost every topic that's there for layer 2. In tomorrow's session, we're gonna have a layer 2 security, spanning tree protocol, a little bit of introduction to you can say IPv6, then access control list, network address translation, and some part of network automation, introduction to network automation. These are going to be the topics for tomorrow's session, which are pretty small topics that we have. So each one of them might take 20, 30 minutes, each of them. And then we'll be good for the training. Tomorrow is going to be the last day of the training. Okay. Soumya is saying if we have two switches, then we can use VTP to VLAN transfer. Yeah, you can use VTP to VLAN transfer. Okay, but that's the concept that you will learn deeper into CCNP study, because there are other things as well that needs to be done. Okay, I hope you enjoyed. If we get time in tomorrow's session, I'll give you a glimpse about VTP as well. Perfect. I hope you enjoyed the class today. Okay, and the recording will be out there pretty soon. Thank you so much for joining in, and yeah, we can learn. Depends on time. Okay, tomorrow is going to be the last session for ourselves. Okay. Meanwhile, yeah, take care of yourself. I'll see you guys tomorrow same time. Thank you. Bye bye.